this video we're going to be tackling solving rational equations. Bit of a typo there. So let's start just by going with x minus 2, x minus 3 equals 0. So we know that the denominator cannot be 0, so x cannot be 3. And if we were to solve this, when I say solving rational equations, we basically want to find out where these zeros are on a graph. So what we're going to do, because if we set this equation to 0 and we solve for x, basically we multiply both sides by x minus 3, x minus 3, 0 times that is out anyways, this will cancel, and you're left with x minus 2 equals 0, so x equals 2, and that means at 2 we have a vertical asymptote, which means, I don't know if we ever discuss asymptotes, but basically it's an imaginary line that a function, if it has an asymptote at that point, at that line, it will get infinitely close to it, but it will never touch it. It'll keep getting closer to it, but it'll never touch it. So this function actually has a vertical asymptote, which goes down like that. I've actually graphed this out so I know what it looks like, but that's basically what we are looking for when we're doing these graphings. So let's look at another one. Let's say we have x plus 3 over x minus 4 equals x minus 1 over x plus 2. So we know right away our two as we cannot have negative denominators. Denominators cannot be 0 here. So x cannot be 4 or negative 2. So let's start solving for this. So what we can do is cross multiply. So we'll have x plus 2, x plus 3, x minus 1, x minus 4. And now let's expand. X squared plus 5x plus 6 equals x squared minus 5x plus 4. And now let's move, we can start solving. We have x squared on both sides, that cancels out. We can move the 10x to one side, 5x and 5x. And then we have plus 6 on this side. We'll move that over to the 4 and subtract it on this side. And we should have a negative 2 here. So we have 10x equals negative 2, so x equals, divide 2 by 10, we get negative 0.2. So that is our solution there. So what else can we do? I wonder. Okay, let's try a word problem now. Let's see if we can do a word problem. Let's say we have a tank which contains pure water, and we have salt water let's say that the concentration of salt in the tank is given by a function c of t, which, and t is minutes, how many minutes have gone by. The concentration is equal to 10 times t over 25 plus t, and c is equal to grams per liter. So now the question is, when does the concentration equal to 3.75 grams per liter? That's what I want to know. So it's very straightforward. If we have our target number that we're going for, which is 3.75, we can say that well, exactly that. And now, once we've interpreted this into our equation, now we just have to solve this very rational equation. So, first thing we're going to do is bring this up to that side, so multiply both sides by that. So I'm left with 10t equals 3.75 times 25 plus t, which will give me 10t equals that. So that'll be 10t is equal to 93.75 plus 3.75 t, and it's looking to be so I'll just take this t over to that side. 10 minus 3.75, 10t minus 3.75 t equals 90.75. So now I'm left with 6.25 t equals 290.75. Divide that and I'm left with 15 minutes exactly. So it will take 15 minutes for the concentration to reach that. And yeah, this one is pretty straightforward. We can also look at when it comes to solving rationals, we can also look at solving rational equalities. For example, I don't know if we ever touched up on inequalities, where we have x minus 2 is less than 8 over x. And now first things first, x cannot be 0, because that would be off. So I don't know if we ever touched up on inequalities, but inequalities are just these rules here that state that this has to be greater than that. So based on this inequality, you can treat this sign here like an equal sign. So what I'm going to do is bring this over to the other side. X minus 2 minus 8 over x is equal to 0. And that leaves me with what I'm going to do is divide I'm going to multiply everything here, all the items here. I don't know why I put equals, it should be like that. x over x, and both sides x over x. X over x is 1, so I can multiply by 1. So I'm left with x squared over x minus 2x over x minus 8. Over that one I'm going to not multiply by x over x, because that will basically give me 8x over x squared, and I don't want that. And that would just divide anyways. Okay. So I'm good. And now I can put everything over x. So x squared minus 2x minus 8 over x greater than 0. And there you go. That is us solving inequalities. There are further rules that we can define for this when this is a positive or negative, like defining its behavior, but probably have to do a separate video on just that, so I'll leave it for now on this inequalities topic. Not really the most popular subject in what's it called? In terms of algebra, so I'll leave it at that, but I can also give you guys this. Solve this. By that I mean find the x, find the zeros. I'll leave that with you and enjoy that. And that's all for this video, and I shall see you in the next one. Okay, so in this video we're going to be tackling radian measures, or the measurement of radians. Really, so up until now, when we look at, let's say, a circle, and say that's the center of a circle, and we have this to here. Usually when we measure from one side or one arm to the next, we measure the angle between these two and say that this is theta in terms of degrees. So let's say this is r, the radius of the circle, theta being the measurement that we're looking for, and then we say that this measurement right here, from here all the way to this line, that is equal to a. So this is where we introduce a radian. So a radian, by definition, is the size of an angle that is subtended at the center of a circle by an arc with a length that is equal to its radius. So another thing to note is the arc that we have here. This arc and the radius are both measured in the units of length. So it could be centimeters, meters, millimeters, whatever it is. is how we are going to be well, that's basically a brief intro to what a radian is. So understand that theta is equal to 1 radian when A and R are the same. So let's see, in the circle, remember, a circle is 360 degrees. Say we have a circle with 360 degrees and we have R here, and that's 360 degrees. And A is equal to the circumference of the circle, which is 2 pi R. So, by that definition, theta, which is equal to A over R, 2 pi R over R, R's cancel out, we're left with 2 pi. So theta is equal to 2 pi radians when it comes to a circle. So when it comes to the circle, when we have, based on our understanding thus far, 360 degrees, we know that based on this being true for this, and also 360 degrees is also true for a circle, we can say that 360 degrees is equal to 2 pi radians, which means that in radians, pi is equal to 180 degrees. And that is how we measure that. So, let us divide both sides. I'm not done here actually. Let's divide both sides by pi, because this is pi radians. Pi radians is equal to 180 degrees. That's true. But continuing this logic, if you divide both sides by pi, you're left with, this cancels out, and you're left with a 1 here. So 1 radian is equal to 180 degrees divided by pi, or approximately 57.3 degrees. I can't stress enough how important this is to understand that 1 radian is equal to 180 degrees divided by pi. This is going to be very useful to you when you need to switch between, or if you want to remember this, pi rads equal 180 degrees. Just remember this, memorize it, and it'll be very useful for you when you want to convert from one to the other. So, speaking of converting, let's tackle that right now. Let me just write that here. 180 degrees. So let's try converting 20 degrees into radians. So if we have pi rad rates, let me just write out the whole thing so we don't get confused. Radians equal to 180 degrees. Then that means 0.35 radians. So all we really did was multiply it by pi over 180. And that gives us what it is in rads. So let's do the same thing with, actually, let's do the exact same thing with 225 degrees. So 225 times pi over 180. You actually get 225 pi over 180. And if you simplify this, because these are both multiples of 45 degrees, so if you simplify that, that should give you 5 over 4 pi. Sorry, 5 pi over 4. My mistake. So, now that we've done that, let's go the other way. Let's go. Say we have 5 pi over 6 in radians, and I want to measure it to, I want to convert this into degrees. So, before, when I went from degrees to rad, I multiplied by pi over 180. Now when I want to go from rad to degree, I want to multiply by 180 over pi. And it's as simple as that. Actually, wait. Let me prove it first. So we have pi radians equals 180 degrees. I'm just going to multiply it here. So I have looking at this formula right here, I'm just going to take this 5 over 6 and put it into here. Pi equals 180, 5 over 6. And that will leave me with 5. Well, if I divide the 6 here, I should get 30 degrees times 5, it's 150 degrees. Now let me do one more just to make sure. 1.75 radians, and I'm going to take this 1.75 and I want to turn it into degrees, so I'm going to multiply by 180 over pi. So that should give me 100.3. And there you go. Yup, looks about right. So this whole radian measurements are very fun to do. It's going to be fun when it gets introduced into the trick section as well. And if you want to try it for yourself, you can, let's say for your homework, I say, convert from to say convert 200 degrees to rad, and then also convert from radians to degrees. Try doing 11 pi over 4 to something, 2 degrees. Try these two and put it in the comments section. And yeah, that's all I got for you for this video, and I shall see you in the next one. Okay, so in this video we're going to be tackling compound angle formulas. So these are more towards trig identities that we're going to be looking at. So let's just start defining them. So let's say we have sine A plus B. The identity that we're going to define is that if you ever have sine A plus B, that is the same as sine A cos B plus cos A sine B. Similarly, if you have cos A plus B, we're going to have cos A cos B minus sine A times sine B. And then if you have tan A plus B, we're going to have tan A plus tan B over 1 minus tan A tan B. Yep. These are the addition formulas. Let's also put in the subtraction formulas, which is going to be sine A minus B. The identity there will be sine A cos B minus cos A sine B. So opposite sign flip there. And we have cos A minus B, and that is also going to be the flip side of that one. So cos A cos B plus sine A sine B, and then we have our tan A minus B, and you guessed it, the flip signs. So you have tan A minus tan B over 1 plus tan A tan B. I don't know how schools do it these days, but back in my day, though I sound old when I say that, we had to memorize all these. They wouldn't allow us a cheat sheet. So I don't know how it is now. Maybe you're allowed a cheat sheet, maybe you're not. So let's look at some examples on how to do these. So say we want to find the exact value of cos of 15 degrees. We can rewrite cos 15 as cos 45 minus 30 degrees, because 45 and 30 are special angles. So if we look at our cos A minus B formula, we can do cos A cos B plus sine A, sine B, which is, if we rewrite it, our A is 45 cos 45, and our B is cos 30 plus sine 45 sine 30. And we know our special angles from our special angles video, 1 over root 2, root 3 over 2. That's cos 45 is 1 over root 2, cos 30 is root 3 over 2, and then sine 45 again is 1 over root 2, and then we have our sine 30 is 1 over 2. So we can simplify all this and get root 3 over 2 root 2. That's also 2 root 2, but that's 1, so that's plus 1. Oh, that's easier. And there you go. So, let's do another one. Let's do tan of negative 5 pi over 12. And that, let's rewrite that as a fraction. Say tan is equal to negative pi over 4 minus pi over 6. That'd be very kind of hard to identify, but the more you do these things, the more easier it comes to you. So remember our identity for this. Tan A minus B is equal to tan A minus tan B over 1 plus tan A tan B. So if we start plugging these in now, tan of negative pi over 4 minus tan pi over 6 over 1 plus tan negative pi over 4 tan pi over 6. So now we're left with that is should be a negative 1 minus, that'll give me a negative 1 over root 3. And I'm getting these from the special angles table, which you should have handy or know by heart, these special angles. But if you don't, you can go through my videos. There's one on special angles to quickly learn how to have them on hand. And now we just have to simplify. So we should get the numerator, we put it all. We can rewrite just that. The denominator will be so there we have it. So let's do another one. And those examples were expanding. Oh no. Let's try simplifying. Sine 2x cos x minus cos 2x sine x. So we should be able to see things like this and identify them and say that, hey, that looks like a compound angle formula, where we identify it as sine a minus b is equal sine a cos b minus cos a sine b. So we can see that that is our b and this is our a. So we can rewrite this entire expression as sine of 2x minus x, which is also just sine of x. See, very simple, very straightforward. Let's do one more where we identify that. Let's do cos 7 pi over 12 cos 5 pi over 12 plus sine 7 pi over 12 times sine 5 pi over 12. So, does this look familiar? The answer should be yes. This is our cos a minus b formula, which is cos a cos b plus sine a sine b. So we have our our b, and our b all in the right places. So we can basically say this is equal to cos of 7 pi over 12 minus 5 pi over 12, which should give us cos of 2 pi over 12, which of course is cos of pi over 6, and cos of pi over 6 is of course as well a special angle, which is equal to root 3 over 2. So that entire thing is equal to root 3 over 2. And we could easily find that with our special angles. Yes, it really is that straightforward. So, for those of you who are interested to have a little practice, try finding this out to the exact value. That is a little bit of on your own thing to do. Put it in the comments, see what you get. But yeah, until next time, that's all for this video, and I shall see you in the next one. Okay, so in this video we're going to be tackling double angle formulas. So in the last one we did compound angle formulas. This one is double angle. So instead of like in the last one where we had compound, where we had sine A plus something B, So sine 2 theta is going to equal 2 sine theta cos theta. These are the identities that we're going to have to more or less get used to and apply and identify and, just keep in the back of our heads. So cos 2 theta, actually cos has 3. The first one being cos squared theta minus sine squared theta. The second one being 2 cos squared theta minus 1. The third one being 1 minus 2 sine squared theta. And finally we have our tan 2 theta, which is 2 tan theta over 1 minus tan squared theta. And now you know all of our double angle formulas. So now that we have them, let's start applying them. I wonder if people will take a screenshot before I wipe it, but anyways, let's start with 2 sine pi over 8 cos pi over 8. So, how can we identify this right off the bat? We know that we have our sine 2x is equal to 2 sine x cos x. So, we know that this is an identity which we can simplify into sine 2x, x in this case being pi over 8, which is equal to sine pi over 4. And we know from our identities that sine pi over 4 is equal to 1 over root 2. Simple as that. What else do we got? We got 2 tan pi over 6 over 1 minus tan squared pi over 6. So, do we know where this one is? Well, it's the only tan one we have, so let's not keep you into more suspense. So, x being what's in the bracket there, so pi over 6. So, equals tan of pi over 3. And we all know that pi over 3 is obviously root 3, because we're so in tune with our trigonometry. So, what else can we do? Let's see. Let's do a derivation just to keep your mind sharp. Let's see. We know that, say, cos 2x is equal to 1 minus sine squared x. Well, what I'm basically doing is creating a formula for sine x over 2 cos x from both sides, so just moving it over. Let's try isolating that. So I'm going to move this term to that side and this term to that side, so I'll have 2 sine squared x over 2 is equal to 1 minus cos x, and then I'll divide it by 2 as well. And then I have the sine squared, so I'll just take the square root. So there you have it, our sine x over 2. I basically just created a formula for it. Literally just to have a formula for it, based off of the identities that we know. So I hope that was somewhat fun to do. I wonder if you guys be interested in doing something on your own. Let me see. Let's see if I can find some questions. Let's say I do question 1. 2 sine 45 cos 45. Give me the exact value for that. Well, of course, first express it as a single ratio, then at the end, you can also do 1 minus 2 sine squared 3 pi over 8. Let's see. You can also use a double angle formula to rewrite some of these trigonometric ratios. So sine 40 sine of 4 theta. So let me just take that out. So try using a double angle formula to rewrite the ratio. Same with maybe cos 6 theta, or even tan of 5 theta. Let's just see what happens. Let your just go crazy. And I'll end this one here. So put it in the comment section below, your answers, and let's see what happens. That's all for this video here, and I shall see you in the next one. Okay, so in this video we're going to be proving trig identities. Trigonometric identities. So based on what we've learned so far in trigonometry, we're going to apply all of that, and proofs are one of my favorite things to do because I used to struggle with it so much. So let's start with sine 2x over 1 plus cos 2x is equal to tan x. So basically I want you to prove that this equals that. So let's get started. I'm just gonna put tan x here, and I'm gonna work with this side here and basically manipulate and simplify and expand and do whatever I want to this with facts just to prove that it is equal to tan x. So one of the first things I'm going to do, I see sine 2x. That is a double angle formula, so I can rewrite that as 2 sine x cos x. And then I also have in the denominator, I had nothing to do with the 1, but I have a double angle here. So what I'm going to do with this, I have one of 3 choices, because there's 3 double angles formulas for, or identities for cos 2x, but I'm going to use this one, cos 2x minus 1, because I'm going to get rid of that 1, and then I'm left with, so these ones will cancel, I'll be just left with 2 sine x cos x divided by 2 cos squared x. And cos squared x is the same as writing cos x times cos x. So as you can see, the 2's cancel. One of the cos x cancels, and I'm left with sine x over cos x, which is the same as writing tan x, which is also equal to what I was trying to prove. So left side is equal to right side. So much fun. Let's do another one. Let's see. Let's do let's say we have sine x plus sine 2x is equal to sine 3x. I want to prove that this, that is not an identity. I want to prove that, so what I'm going to do is say let x equals pi over 2. So if I sub in this pi over 2 into here, sine pi over 2 plus sine 2 pi over 2, that is going to be a 1, that is going to be a 0, so 1 plus 0 is equal to 1. So my left side is equal to 1. However, my right side, sine pi over 2 times 3, that is equal to negative 1. So my right side is equal to negative 1. So left side does not equal right side, therefore it is not an identity. That is us disproving it. So we made quick work of that one. Very easy, we just plug in a simple number and check. Now let's go back to proving. Let's say we have cos pi over 2 plus x is equal to negative sine x. So let's work with this side here. We know that this right here is a compound angle. So remember our cos A plus B formula. So we're going to expand that here, and so basically we're going to have cos x minus sine pi over 2 sine x. So we know that cos at pi over 2 is 0. And we know that at sine of pi over 2 is equal to 1. So this is going to be 0. So this whole thing can cancel out. And I'm left with this 1 here. This becomes a 1 because that's what the identity is, and I'm left with negative sine x, which is also equal to the right side. And that, honestly, these are moving a lot faster than I expected. I was not expecting to get this quickly into it. Okay, let's try one more, a little bit more bigger. Let's try cos x minus y and cos x plus y. Let's try to prove this is equal to 1 plus tan x tan y divided by 1 minus tan x tan y. So let's look at the right side alone. So let's try expanding this. I'm going to look at just this side. So I have 1 plus, and if we look at the tan x, we can rewrite tan x as, sine x over cos x. And then we can write this tan y as sine y over sine cos y. And then in the denominator we can do the exact same thing. 1 minus that sine x cos x sine y cos y. And then what I want to do is multiply everything so that we can have a common denominator. I want to add the 1 to this and the 1 to that. So I'm going to multiply the numerator by cos x cos y over cos x over cos y. And then once I'm able to put all these under the same denominators, then I'm able to do this because I'm multiplying both of them. So if the numerator gets multiplied by cos x times cos y, this denominator here goes away, and that becomes cos x cos y. So cos x cos y plus sine x sine y. That's the numerator. Now for the denominator, same thing. I multiply this cos x and cos y into this 1. I'm left with cos x cos y minus, and this denominator goes away, and I'm left with sine x sine y. And now you can immediately identify that this numerator is a compound angle formula for cos. That is cos x minus y formula. And look, the denominator as well is the compound formula of x plus y. And guess what? That is our identity that we were trying to prove from the very start. This is why I like trigonometry and math. Everything is either it is or it isn't, and we can prove it. There is no opinions in math. It just is or isn't. Let's do one last one. Tan 2x minus 2 tan 2x. That's kind of long, so I'll write it over here. Let's write sine 2x is equal to tan 2x minus 2 tan 2x sine squared x. So I'm going to try to take this and manipulate it into becoming that. So what I'm going to do is, first of all, I'm going to factor that out. Tan 2x, that'll give me a 1 minus. So I took a tan 2x out, so I should have 2 sine squared x. And I know what that is. That's one of my cos double angle identities. So that is tan 2x I'll just write that here. Cos 2x. And let's rewrite this as because we have tan is tan 2x is the same as writing sine 2x divided by cos 2x, and we still have this cos 2x here, so this will cancel with that, leaving me with sine 2x, and that is my identity proven to and through. So that is us proving some identities with everything that we've learned. Thus far. And I'll leave you with something, to practice if you want. Something. Well, here you can do. Well, I want to know how you could type this out into the comment section. Well, you can try it. Cos x tan cubed x equals sine x tan squared x. Try proving that. I mean, if that's easy, then you can try like cos 2x plus 1 over sine 2x equals cotan of x. I mean, try both, see what happens. Enjoy life. But yeah, that's all for this video, and I shall see